Okay, we've got this function f of x equals the square root of x, and the point 4 comma 2 is on the graph of that function, and you're asked to determine what happens to that point under these transformations. Before we go to Desmos and see what's actually happening to that point, let's just talk about real quickly what these numbers do to the original point. Okay, these numbers right here, circled in red, are, quote, inside the parentheses, or close to the x value. And a number that's being multiplied times x, like this 1/4, if we use the reciprocal of that number, that causes either a horizontal stretch, in this case by a factor of 4, the reciprocal of 1/4, or horizontal shrink if this number was greater than 1. The plus 1 causes a horizontal shift to the left. So these two numbers, the 1/4 and the plus 1, are causing changes to this 4. We'll see that in a second. The numbers circled in green cause changes to the y value. This minus 3, that was a plus 3, it would cause a vertical stretch by a factor of 3. In other words, we've determined what this value is, and now we're going to multiply it by 3. The fact that it's negative causes a reflection over the x-axis. And the minus 5 just causes a vertical shift by down 5. Okay, now if I go to Desmos, let me do this. There's the graph of the original function with the 0.42 showing. If I now say that f sub 1 of x is f of 1/4 x, that's going to cause this point to shift, stretch by a factor of 4. Watch. Okay, so to get to the same y value, which is 2, we have to go all the way out to 16 to reach a y value of 2. And that's what happens because of the 1/4. We have the horizontal stretch by a factor of 4 affecting the x value. Now watch what happens if I do a horizontal shift left. I'll take f sub 1 of x, which was this green function, and shift it to the left one, call it f sub 2 of x. And it's hard to see, but there it is right there. Now, because of the horizontal shift left, the x value is 15. We are done with the changes to the x values now. 2 horizontal transformations. Now we're going to have a vertical stretch by a factor of 3. Let me enable this one first of all. So now the y value is stretched by a value of 3. We're still at the same x value, 15. But if I change this to a minus 3, we're down here. Same y coordinate, except it's the opposite. We reflect it over the x-axis. Okay, so right now we're at 15 minus 6. Finally, we're going to do a vertical shift down by 5. And that just means we have a minus 5, quote, outside the parentheses. There it is, way down here. 15, minus 6 became a minus 11, down by 5. So the 0.42 under these transformations becomes 15, minus 11. Now you're asked to do this with a mapping. So the 0.42, I'm not going to write this all out, but the first mapping is a stretch by 4. That takes you to 16.2. And you probably have a symbol in here for what a horizontal stretch is. But then we go to shift left because of this plus 1, 15, 2. And now we work vertically. Reflect over the x-axis by a factor of 3, so this becomes 15, minus 6. And then down by a factor, by a horizontal vertical shift of 5, minus 11. Okay, there you go. Hope that gave you some idea of what's going on. If you have any questions, post a comment.